Okay, so in today's video we'll be picking back up where we left off of the UDT scenario, using a UDT for the motion commands and motion application. So real quick to kind of go over things, we made our UDT, our basic UDTs, which do our on-offs, resets, and stuff of that nature. Our advanced, which does our arms, watches, stuff like that, which we're not going to be expressing too much, but I want to pick back up and kind of briefly go over where I was. Again, it's Emulator 5000 chassis, version 20. We named our processor Motion UDT. We're in slot 1. We did throw in physical hardware, but just to show a representation of linking and access in an associated access module to a physical hardware. I'm not using these because I'm using an emulated software, so I don't have any physical hardware, but I do want to represent, give a good representation of what to do at that instance. We are using a 47 millisecond scan rate for our main task, and all the main routine does is jump the subroutine over to the motion control. So in this video, I kind of like to show exactly how to do, we're going to run through our sequence again, but we want to add steps to it. So before the stop, I want to go ahead and do like a speed change. So what I'll do is I'll come in here and add a couple speed change elements, and what we'll do is we'll say, and right here we'll say if it's in this happens to be in state 6, which is already jogging, we want to be able to go ahead and change we'll put this down here, but we'll change that to a motion axis, change the motion direct commands or dynamics. So let's come over here to motion move, and let's get a motion change dynamics. Again, we don't have to change anything but our, because they're geared together, we don't have to change anything but our virtual axis 1. In motion control, we want to again use our UDT, so motion basic, our axis 1 basics, and then we'll come down to our dynamics. Come down to motion change dynamics, and we'll pick the very first one. And as far as the motion type, we want to have it's a jog. We want to change the speed, yes. The speed, we're going to add in a tag. We're going to call it speed change, and then we'll keep it as like a dent. So acceleration, we'll change the acceleration by 200 milliseconds, or 200, and then we'll basically come down to accelerate rate. So we want to, I put that in wrong, sorry. So we want to change our rates. No, we don't actually want to change our rates. That's just not in this instance. Right, so let's just throw in some default values right here, and no for the decel. Throw in some generic. So we don't want to. Again, we don't want to really kind of just. We want to kind of fill in the data. We don't want to. We're not going to use it. Not in this instance. So with that said, decel jerk. Speed units, again, we'll come in and put in our speed units, but it's kind of cut and dry because we're not really using them. So what this is going to do is it's going to change the speed, right? But so we don't have a speed loading in here yet. So what we will do is we'll come in, and to show a representation of how to change that is we'll come in and we'll do a previous speed and then like a current speed. So we'll go to a compare, and we'll say if the speed change is different from the current speed, or say for instance current speed, and we'll keep that as a dent 2. If it's different, so not equal to, but so if it's not equal to, then what we'll do is we'll cut on a bit, and we'll call this bit speed change active, or let's just call this speed change, update. That way it keeps it kind of simple. You know exactly what I'm doing. And then the very end of this, we want to move in. The speed change. So what we should do, actually, we should put current speed down here, and then we should put speed. So that way we have the speed we want to change to, and then we'll come in and put the current speed down here, and then we'll put the speed change right here. So what's going to happen at this point is we'll come in and throw in basically exclaim when closed, and basically, so what this is going to do is when that goes high, when this bit goes high, it's going to change the dynamics. If you did not have that in there, you could change speed all day long and it would not affect anything. So with that said, so let's go back and straighten out our state controls. So again, we're gonna jog at jog, and as soon as the jog hits a in process, it's going to go to state. It's going to move into 6 into the state. When the state hits 6, you have the ability to change speeds. So we can copy this, paste this here. You have the ability to change speeds. In that case, we want to, we don't necessarily have to do a state change on that. We can just keep the stop as the way it is, or we could come in here and change that as well if we wanted to. So real quick, let's just kind of show an example of how that works. So what I want to do is go ahead and we'll put a speed change in here. Let's just throw this into like a 25 or 20. So keep in mind we're going to start out with a value of 10 in the speed change on the speed. It's going to have a velocity of 10, and then we're going to change it to 20, and then I'm going to change it several different times to show you that the motion change dynamic works. So let's go back up and reset everything in our start sequence, our start motion sequence. So we started the motion sequence. It is now at a 3, so what we're going to do is home it. Okay, so everything is homed, and we geared them together when we homed. Alright, so everything is completely at 0. We verified that both axes are at 0. They're both at a velocity of 0. And then we want to run that. So immediately you've seen it transition to 20. So let's just say, for instance, let's go to 30. And you see the speed jump to 30. Now, if I take out, let's do this. Let's take this out. And I want to show you what it does without it. So if I change it now to like 40, it does absolutely nothing. Because of the fact of it's not interrupting the current rung. So you're not resetting this this enable and done. You're not resetting that at all. So what you have to do is you have to put in basically examine and then you come in here and you push at it, and as soon as that goes high, then it will change it. Now it didn't change it to begin with because we've already changed it, so that bit was not active. So let's take, for instance, let's go to 25. So the speed changed, and the speed, you see the speed, current speed did change. So with that said, you can speed these up as quick as you want to. We can put it at 100, and you see how fast the servo is moving at that point. So you can see up here what's happening, and that's actually showing how to change the dynamics. Now, what we can do is we can change this jog to a MAM. So what we can do at that point is come in and actually, let's cancel this, and let's go ahead and reset the whole sequence, right? So I want to reset everything, and I want to change this to an MAM. And then when I do that, I want to change this from, I want to change this from a jog, from the jog UDT to the MAM UDT that we want to use. And again, it's not going to have anything in there, right? So the speed, we want the speed to be, let's do the 10 again. And the acceleration rate, so speed units is going to be units per second. Let's say, let's put the speed rates. We'll put some default values in here real quick. And again, this is quickly filled out. Profile, we want trapezoid. Decel rates. So the jerk is fine. Let's see. The decel jerk, let's keep it at 100. And the lock direction, I believe I want these at 0. So at that point, we have to change our IP again. So what we want to do is we want to have the process complete bit, because I'm going to change the way this is programmed a little bit. So we'll come down here and we'll put the process complete, and we'll throw the process complete bit in there, and that way when this finishes, so we'll give a position, we'll throw the position that we want to run it to at 500. So when both servos hit 500, it's going to stop. Or when the MAM hits 500, it's going to stop, and the process complete is going to throw this to 6. Okay, so we don't exactly have the ability to accept this yet. So let's see what we're doing wrong. That's the MAM. Let's see. Let's accept this real quick. See what happens. Yeah, I know that. Okay. Oh, there it was. And that's what happens sometimes when you change the way you use an instruction. Like if you change the instruction, motion instruction control, then it's going to have, you're going to have to change all this as well, because it fits the old pattern. So real quick, we're going to go into 6 at that point, and now we want to change our values of 6. We want to actually come in and let's add in, if this is at 6, so we're going to change this to 6, and then we're going to say, okay, well, now we want to throw our jog back in. And the reason I want to do that is to show that we can use this with a speed change. So I want to show kind of the versatility of it, you know, like start a jog. Of course, we're going to copy this. We're going to come back and paste this in here. We're going to get rid of this, or actually we're going to call this, let's see, move PB, and then we'll make the tag. As soon as we make the tag, of course it accepts. So now we have our jog down here. So let's again throw our jog in there. And we know we need to have our jog, our motion access jog instruction, right? So we'll throw that in there, and then we'll throw the bit level of the IP in there as well. That's what we're going to change states with. So real quick, we're going to select our virtual access 1. We're going to come down and select our basic parameters, or our basic UDT that we had selected. We're going to go back down to jog. We're going to select jog number 1 again, and then we're going to say the direction 0. We're going to say the speed. We're going to start it off at 10. The units, again, we're kind of just throwing in default values as a representation, right? You may want to use these differently in your live instance, but this is showing you how it's done. Just basically through our this is going to be a trapezoid. You can do S-curve if you want. Honestly, it's probably best to use trapezoid for most things. There are instances where you you would use a S-curve. I have used it before, but most things that you're doing is pretty sharp stops and starts, so trapezoid is perfectly fine. And if you wanted to show a representation of that, quickly go to help. All you got to do and see how a trapezoid versus a S-curve works. Scroll all the way down. I want to say it should. Okay, so it may be under related topics, but like S-curve and stuff of that nature. But you can see how it will work. Yeah, so we won't get too far into that. We'll just go ahead and get all this to work. Disable speed merge. We're going to put in 0 because we don't want to speed merge. We don't want to lock. And then we'll come down and throw our instruction IP in there. In process again. So remember that's in process. We're going to throw a move instruction for our state control. So our move instruction for our state control, and we're going to throw in a 7 instead of a 6. Down here, we want to change this to now a 7, and then change this to a 7. And then come down and fix this as soon as it hits. Yeah, okay, so as soon as it hits 7, so we want to go ahead and do this, make this an 8. So with that said, we'll put that as an 8. Come down here and say 8 for the last state. Okay. Now a lot of that kind of happened really quick, and that's the point I'm trying to get at with modular programming. Is you can kind of tell what's going on, but real quick we'll run through that. And I know we're kind of running a little long on this video, but I'll start the sequence. We immediately went to our state 3. Now again, you see that we have data in our actual positions, but we're not running. So as soon as I hit home, then I have homed the axis. Now I've geared it together, right? And then what I want to do is now I'm going to index the move. Well, I'm only moving the axis 1, and I'm only moving it to a position of 500. But both axes are going to run because we have them geared together. So you kind of need to leave this bit live, because as soon as the process complete happens, it's going to transition into a 6. So what will happen is the servos will stop when they hit 500. So keep in mind our position right here is 500. When these positions, it's actually only looking for axis 1 to hit 500. because that's the only one we're controlling. But being that the gear command we have up here is gearing the virtual axis 1 to virtual axis 2 to virtual axis 1, we're going to actually, it's moving both of them. So if you've seen right there, they moved to 500, everything stopped, so there's no more velocity. We can then untoggle that bit. Now we're in state 6. Now in state 6 we want to issue a jog again. We issue a jog, we start moving again. You do not have to keep the bit live on a jog. So in that instance we did not change the speed command. Not sure why. Hold on. No, that was right. Okay, so speed change. No, that's supposed to be 7. This was supposed to be 7. So it's falling back into 6 for some reason. Let's see why. We probably have something wrong with our state control. Oh, well, this shouldn't be happening because it's not on. So in state 6, let's look at every one that gets loaded. Move. Okay, so it's only going to index if that's on in a state 6. So state 6, going to cut on a jog. Cut on the jog, goes into state 7. So cut in here, we go to state 7, and at that point you can kind of leave the jog on at this point. You shouldn't have to, but again I just want to show the speed change. So let's move this down to here so you can see the speed change. So again, the virtual axis 1 and the virtual axis 2 velocity is at 99, which is showing the speed change is 100 on the dynamics down here. Let's change this to 25. You've seen it went to 25, everything slowed down, started working. We can even slow it down as slow as we want. So very minute. I just wanted to highlight, how to use the motion axis move as well. As far as that, adding it into the state control, and then coming back and following up with a jog if you wanted to. In that instance, you can put the jog stop. What you can do down here, instead of putting a jog stop, you can put in the reverse of this. So we can copy this, come down here, and we could say, let's delete this, let's put this in here. And what we can do is turn this into the opposite state, and that will stop it. So in that instance, it does fall back into a 6. So again, that may be because I have to look at look at why that's happening. Yeah, so that's in 7. Moving a 6 in here. Alright. None of this is active, so must be forcing a 6 in. Oh, here's what it is. Well, no, that wouldn't do it. So let's leave the stop in there for now. So the stop push button, and we'll come back and use that. So we'll come back and toggle this back on for the jog, and then use the stop. But we want to transition to a state. So this was in state 7. We want to transition to a state 8. It's jumping back into a state 6. So I know this video is kind of running out long, but let's just figure out why it's jumping into 6. Maybe I threw in some stuff a little bit differently. Shouldn't have. So this is going to 7. This is going to 7. Or if 7 allow speed change, if 7 allow dynamic change. Alright, so if 7 allows stop. Yeah, if 7 allows stop. But if I hit stop and it's in jog, oh, I see what happened. Okay. So we issued a stop. We issued a stop. Now this should go on to 7. The 7 is going to come down here, and we're going to go and do our dynamic change. We should probably throw some states in here and to kind of clarify that up and clean it up to fix it. But in the meantime, this actually shows you, how to program this and get it to the point where you want it. So again, I just wanted to represent the actual using the, so this is dynamic change. This is alright. So but we wanted to illustrate the fact of using the UDT for more of an advanced function like a MAM, move to position, then still use the jog and still use the motion dynamic change as far as the speeds. So just keep in mind when you're using that feature that you use the update tag, so you break this wrong. If you don't break this wrong in the motion change dynamics, then you do not actually change the speed. So the speed right here won't change. And that's the only reason I have this wrong in here, to represent I don't have to go to the tag database and pull it up, and show you exactly what's happening in the tag database. You can kind of see it real time. Normally I wouldn't put this in there, but just as a representation of this video, I am. So with that said, this is pretty much, I'm running kind of long on this video, but I want to kind of throw a conclusion to this and kind of show you how to do that. So let's see, stop. Let's change it to an all. That's probably best anyway. So you can itemize it if you've seen that. You can itemize it to whatever you want. You can do all kind of stuff. Gearing, you can stop gearing, you can stop. So if we wanted to, we can stop the gearing on it and just run the one. You can do all. So if we did all, I believe that would break our gearing. No, it didn't break our gearing because we're not in. Okay. Oh, and real quick, like I said, that's just that's how you would use that. And I have a different video I could show you if you wanted to run through the sequence of events a little bit better, but this is just showing a UDT scenario, how to use UDT for modulus program. Basically a quick way to come about not having to make your tags and not have to reload your different tag database or having to type all this stuff. It's already pre-done, and pre-done that what you did over here in the UDTs. And as far as that goes, that's how you would use that. So if you have any questions, have any concerns, or would like to see more, just leave me a comment in the comment section below. I'll have the other videos in there in case you wanted to reference the other videos, but in that same instance, yeah, this gave you a good indication of still using adding an MAM and having a dynamic changes and as far as speed in there as well. So again, I apologize for this running a little long. I know 30 minutes is quite a bit of time, so normally I like to keep about 15 minutes, but it's, I wanted to kind of highlight a couple different aspects. So again, thank you for your time, and leave me a comment in the show notes below if you'd like to see more. Thank you.